CBSE 9th Chapter 2 Polynomials. Introduction about polynomials. In this chapter, we shall start our study with some particular type of algebraic expressions. That expression is called polynomials. For example, the expression x plus y, x minus y is equal to x square minus y square, and one more example, x square plus 2xy plus y square. And consider one more example, x square minus 2xy plus y square. All are represent particular type of algebraic expressions. These are called polynomials. In this chapter, we shall also learn remainder theorem. And factor theorem. And their uses in factorization of polynomials. And consider the expression now. Some expression p of x is equal to an x power n plus an minus 1 x power n minus 1 plus an minus 2 x power n minus 2, and going, the last one is a1 x power 1 and a0. This expression is called polynomial with one variable, that is a variable x only here. All terms an minus 1, an minus 2 and so on, a1, a0 are coefficients of given terms. So coefficients of a given terms. This p of x is also represented by g of x or h of x, and anyway we can write, or r of x. Anyway we can represent this expression as a g of x or h of x and r of x and going. Now, degree of the polynomial. So degree means the highest power of the given expression. In this expression, the highest term is here, highest power is a n. Therefore, degree of the expression is, in this line, the degree of the expression is n. So, some example, consider example, say x square plus 2x plus 1. Here the highest power is 2. Therefore, degree is equal to 2. And type of the polynomials. So type of the polynomials. The first one is a zero polynomial. So zero polynomial means zero polynomial is a constant. So a constant zero is called zero polynomial. A constant polynomial 0 is called zero polynomial. And constant polynomial, a non-zero constant polynomial, is called constant polynomial. Zero polynomial is a constant polynomial. 0 is called zero polynomial. Constant polynomial, that is a non-zero constant polynomial, is called constant polynomial. For example, some number 2 or 5 or -7, all are constant polynomial. Let us discuss their degrees. Degree of a zero polynomial is what? Degree of a zero polynomial is not defined. That is a very important one word. Degree of a zero polynomial is not defined. And next important one word is constant polynomial. That is degree of a constant polynomial is, zero. It's also an important one word. So degree of a zero polynomial is not defined. Degree of a constant polynomial is 0. These two are very important one mark. And move to linear polynomial. We move to linear polynomial. Linear means the polynomial having degree 1 is called, the polynomial of degree 1 is called a linear polynomial. And quadratic polynomial, a polynomial having degree 2 is called quadratic polynomial. And cubic polynomial, a polynomial having degree 3 is called cubic polynomial. And biquadratic polynomial. So biquadratic polynomial, a polynomial having degree 4 is called biquadratic polynomial. In the above discussion, we have deal with only one variable, that is here only x terms only. So here deal with only one variable, that is simply known as polynomial of one variable. These are called polynomial of one variable. Polynomial of one variable. So some example, that is x square plus 2x plus 1, and sometime y square plus y. And so having only one variable means that is named as a polynomial of one variable. We can also have polynomial of more than one variable. Polynomial in more than one variable. Polynomial in one variable, polynomial in more than one variable. Give some examples for that line. The example is x square plus y square, some 2xyz. Here x is one variable, y, xyz. Therefore, it is not a polynomial in one variable. That is polynomial in more than one variable. And one more example also, some u square plus v square. It's also polynomial in more than one variable. So now highlight the important lines in introduction. So in this lesson, we are going to learn remainder theorem, factor theorem, and their uses in factorization of polynomials, and degree of the polynomials, type of polynomials and their degrees, and some polynomials are polynomial in one variable, some are polynomials in more than one variable. Now we move to exercise. First exercise. in textbook, so exercise 2.1, so page number 32. So in NCERT textbook, page number 32. The first question is, which of the following expressions are polynomials in one variable and which are not? State reasons for your answer. Here the question number 1 have 5 divisions. The first division, we move to the first division, that is 4x square minus 3x plus 7. Then division number 2 is y square plus root 2. And division number 3 is 3 root t plus t into root 2. And division number 4, y plus 2 by y. And division number 5, x power 10 plus y power 3 plus t power 50. Now write the answer. This is a polynomial in one variable. It's a polynomial in one variable. One variable. Because it contains only one variable, that is x. It's a polynomial in one variable. And the number 2, division number 2 is also polynomial in one variable. Because it contains the variable y only. For polynomial in one variable. And division number 3 is not a polynomial. Not a polynomial means, write the reason also. Not a polynomial. The reason is, here the exponent of t is the exponent of t is 1 by 2. It is a fraction. So the power is of the form fraction. It is not a polynomial. Therefore, it is not a polynomial in one variable. It is not a polynomial. And then division number 4 is also not a polynomial. Why? The second term is 2 by y. That is equal to 2 into y inverse. That is, a power is a minus 1 here. Or power is minus 1. This is not a whole number. Write the reason. Exponent of y is not a whole number. For division number 4 is not a polynomial. The reason is the second term 2 by y is equal to 2 into y inverse. The exponent of y is not a whole number. And division number 3 is a polynomial of more than one variable. That is polynomial in, so actually here x, y and z. So polynomial in 3 variables. This is a polynomial in 3 variables. Question number 1 over. And move to question number 2. Our question number 2 is, question number 2, write the coefficient of x square in each of the following. Here totally 4 divisions. So question number 2 and division number 1. 2 plus x square plus x. Question is coefficient of x square. Therefore answer, the coefficient of x square is 1. In front of x square it is a plus 1. That is a coefficient of x square equal to 1. And number 2 division, 2 minus x square plus x cube. So answer, here minus 1. So coefficient of x square equal to minus 1. And the third division, pi by 2 x square plus x. Here the coefficient is pi by 2. Therefore, coefficient of x square equal to pi by 2. And the division number 4, root 2x minus 1. Here no x square term. The terms are x term and the constant term. The missing term is x square. Therefore, coefficient of x square equal to 0. Now question number 2 also over. Thank you.